Welcome to the Skapa Podcast, Creating the Future with me, Michael Brasseur.
And me, Rob Murray.
The Skapa Podcast invites visionary leaders across various industries to talk about the future and their vision for it.
And together what we want to be able to do is really explore what it would take to turn those visions into a reality and discuss the necessary innovation, strategic shifts, and the collaborative efforts that are required to really genuinely bring about that transformation across defense and security.
And just to be clear, Rob, just as we discussed, this isn't about the past or the here to now. This is about the future and translating big, bold ideas into reality.
So with that in mind, today it is an absolute great pleasure to have Saab's very own rocket man, Marcus Wandt, who has an incredible and wildly impressive career spanning both aviation and indeed space exploration. Marcus was the third Swedish astronaut to go into space, and this year spent 18 days at the International Space Station, prior to which Marcus has been an exceptional test pilot in Sweden, holding the role of chief test pilot for Saab. And after returning to Earth earlier on this year, has become the corporate and group's chief innovation officer. So Marcus has very much a unique perspective on these areas of innovation, adventure, and quite frankly, where humans may go in space. So Marcus, a thrill to have you on the Skapa Podcast.
Thank you. Yeah. And Marcus, welcome to San Diego. You've totally engaged and energized the Skapa team. We're very, very happy to have you. And we're very happy to engage you in this very important discussion about the future and your vision for the future. So the first question I wanted to ask you was, as you look out and you imagine what the future of space exploration looks like, whether it's airborne, space autonomy, or just exploration in general, what do you see? And you obviously have a unique perspective that we're very excited to hear about.
Yeah, thank you. First, I just want to say it's great being here. And you said I energized. I was also very much energized by being here and inspired by the work that's going on here. When it comes to the future ambitions, there are so many things going on, and it's interesting. I get these questions about autonomy and space exploration and human space exploration. Why would we go there as human when we can do it with autonomous vehicles and the automation out there? And that is a very good and a very valid question. And but I think after having been there, I think it's really important for us to use autonomy to get and automation and artificial intelligence and everything that is growing really fast now, to get as far as possible. But I think it's also important for us to get out to that boundary as human beings and observe and see, and by using our cognitive capabilities, realize then and there what might be important for us to continue to explore, because that might not be exactly what we went out there to get. Going out into something unknown and really pushing the boundaries and aim far out into uncharted terrain gives you the possibility to explore and find things that you didn't even know you were looking for. And that is hard to do with automation, which is targeting something that you designed it for. We might get there, we might be there in parallel with that, or I think we will be there in parallel with the automation and the tools we have to do exploration. But I think it's super important for us as a species to get out there as well and be able to find all those key knowledge parts and things that we didn't know exist and we didn't know we were looking for, which then we can bring back and utilize to get even further and push those boundaries. I think that's super important to me, and a lot of times I get very inspired when you go out there in something unknown and just find things.
Yeah, that's a fascinating sort of while while the technology is advancing, where robots and other forms of technology could do this, you see very much a human aspect of discovering the uncharted, whether it be in space or wherever.
Yeah, I think even if when you build a robot or a system with a lot of sensors and go out there, and maybe sensors that pick up things that we cannot see or sense, and looking at that data, then that can trigger, with our mind, other things you want to explore and find knowledge in. But also by being out there and seeing and feeling, and now I use the word feeling because that's something we don't really know maybe how it works. But sometimes the instinct takes over. Oh, maybe this part is what we should be looking, even though we were targeting something that was a little bit more shifted to the left. Now we're going here instead, and that's really interesting. And I've seen that so many times where all of a sudden, by instinct, feel that, oh, this is interesting, and you find out, yeah, that was actually the important part that you found out during that mission.
Yeah, I can totally relate. Not only to my experiences here at Skapa. Obviously, I've not been to space, but we're on the leading edge of tech and robotics and artificial intelligence. This is so much a human endeavor.
Yeah, 100%. I wonder if I can come back to that word, Marcus, you used there about inspire and inspiration. And I wonder if, given your very unique experiences as both a test pilot and an astronaut, if there are areas which, have really inspired you to lean into further, if there are real sort of specific technologies or just ways of thinking or ways of working where we should be leaning further into this.
Yeah, I think there are a lot of, I don't know if it's key moments, it's more maybe context, but something that I've learned throughout this is to be very careful about when to use the word impossible, because a lot of times I've sat down with the experts, and sometimes I had the thought myself, like, oh, this seems impossible. But as long as I don't understand why it would be impossible, it should be considered maybe unlikely or difficult or challenging. But those are very different words from the word impossible. So something I'm very careful with is to say that can't be done, because most of the time it can be done. It's just we just haven't tried, or maybe we tried a decade ago, 2 decades ago, 5 years ago, but now things have changed. Now we have new tools in our toolbox, and all of a sudden it can be done. And I think that's something I've seen several times where experts and people in the domain that you're working in have honestly thought, I believe, that it is impossible, that things cannot be done. Maybe because it's been tried before, or maybe because it just seems to be maybe not rational to do it right now. But that is not the same thing as being impossible, because all of a sudden you find a good reason to do it, and then you should try it. And a lot of times you find out that it wasn't impossible.
So it feels like there's a wonderful book written by I'm pretty sure she's a Stanford professor, a lady called Carol Dweck, called Mindset. And that is all about trying to shift one's mindset from a fixed mindset where people see the here and now and very, very focused on how things have been done historically, and trying to change that to a growth mindset where actually it's what you've just described there. And so I wonder if the source of inspiration for the future when it comes to various technological breakthroughs and what have you is actually perhaps more a psychological one and is more a cultural one.
Yeah, I think that's a very good point. And mindset is everything when it comes to whether you're gonna succeed in something or not, especially when it comes to difficult things. And when it also to have a vision or identify what you are passionate about or what your coworkers or your team is passionate about. Because if you're doing something that you really feel for and that you want to achieve, not only because someone tells you to, but because you really want that to do, you're passionate about it, I think the brain will continue to work. When you leave work that day, if you haven't solved a problem, you hit a threshold or something that seems to be a blocker or something that you want that you didn't solve, if you're passionate about it, you will continue to work that problem. Your brain will continue to work that problem for you, and you will continue during the weekend as well. It's not going to take energy; it's probably going to give you energy, and then all of a sudden you will have solved the problem. If it's something that you don't really feel for, you probably, when you hit that wall, you will just say, "Okay, it couldn't be done. I'm just going to leave it at that." And so I think it's super important to find something that you are passionate about and that your team is passionate about, and have that vision together to work towards. I think that's so the psychological perspective of why you're doing something, I think, is super important when it comes to achieving difficult problems or solving problems.
Yeah, and I just kind of actually wanted to pull that thread a little bit more. And you talked about your team, and as you build a team, what are you looking for? Because sometimes you can go really heavy on experience, and those experienced people might be telling you, no, that can't be done. I tried that, and it can't be done. Or you can go with less experience but more energetic, and they will challenge those experienced folks and say, well, have you thought about this? Have you thought about that? And can you tell me how you build teams and what you look for on your teams? To help realize these kind of big, bold visions that you were talking about earlier on.
I think those were really good points about them. And because experience is important, I think, in the way that you don't have to maybe try all aspects. And sometimes you can realize that, okay, we did try this, and the parameters around you have not changed enough for it to achieve another end result. But on the other hand, it's super important to have that energized, non-biased, open-minded approach. So I think a mix is what I will be looking for. And I think experience is super important, but with experience, without the energy, without the passion, you will still not get anywhere. You just sit there. So I think that's to have someone to pull from and discuss with. That's important, but you also need that challenging approach and the almost, I don't know, it's good if you don't know that it was impossible a while ago or that it was difficult a while ago. So that I think that to have people in the team that just don't know that it's difficult. I think that's super important. So you can just head into it without knowing how difficult this will be.
I agree 100%. I agree 100%. Rob?
So is it fair to say then, when we're trying to map out a sort of a big, bold vision for the future, from your experiences, is that the technology is maybe the last thing we're thinking about? This is more a people business and getting the best out of people.
So so when you want to do innovation, if you want to create something new, I think a lot of times first you have to have the idea, right? And you have to, I want to do this, or at least an idea where to start or what to aim for. And then a lot of times we go to technology and see whether that can be done technological wise or not. And I think, and I've seen several times where we have solved the technology, but then we end up stuck in a process we built a while ago for some other technology or some other reality. And when we have gotten over that hurdle, it's culture, it's mindset, it's people, it's how we think about these things. So even if we had an idea, we created the technology, we still have to convince ourselves to use that the way we wanted to and to reach those goals. And that is not always, that is actually I would say, argue that is the most difficult part, to change that culture or have that cultural development or keep pace with our technological development also culturally. I think that's a big challenge, and it's a really interesting challenge as well. Something that is very important, I think, when you want to make progress, when you want to break new ground, is to be willing to take a risk. And when you take a risk, well, my view on taking risks, I look at what I want to do. I try to look at, and normally as a team also, you look at together at what are the risks here, what will the consequences be if the risk falls out, if this happens, and what is the value or what we're trying to do. And if the value is a lot higher than the risk. And if the consequence of the risk is acceptable, just go for it, even though it's a risk. Mm-hmm. And if the risk is not acceptable, then try to mitigate to get it to an acceptable level. And also consider if you can do it in some other way. And if you do the analysis and you see that, well, the value is not really there. This is just something that we thought we wanted to do, but it actually doesn't have value, then maybe not take that risk. Mm-hmm. But when you see things that you want to do without taking a risk, you will not get there, right? So mm-hmm. I think that's something that's very different in different cultures, within different campuses I've seen, different countries maybe, and different environments. Mm-hmm. And it seems to be a recipe to success, to be willing to take those risks, but do it very deliberately and walk into it with your eyes open, not just close your eyes and hope for the best. That's not something I believe in, but be willing to take a risk. I think that's really important to make progress.
Yeah. And I got to agree with you 100% on that, Marcus. For the type of work you do, the type of work we do, really the new capability is on the other side of failure. That's where the discovery is. That's where the game-changing technologies exist. And there's also a risk of not trying. And I just really thank you for highlighting that point.
And I think it's great that you bring up the word failure, because what is failure? So if you're aiming for something specific, we want to get to some point, and you start walking that path that you believe is the right path at that point, mm-hmm. and you only get halfway, and you have to stop and walk back and find another path, or you didn't even get to the point, but you got a lot of knowledge and a lot of value on that road towards that point. Is that a failure or not? Was it a failure because you didn't reach the point, or did you create value matching the effort anyway towards that point? So it's sometimes you have to be willing to fail, if that is the right word, mm-hmm. to achieve what you're trying to reach. But and I don't know, sometimes I just want to redefine or use another word, like okay, we didn't get there, still not a failure.
100%.
And so, and I think that's the point, that failure is not fatal, but often we have it in our minds that that taking that risk and what have you is a problem. And actually, this is very much a biological issue. That we have evolved as humans over millennia from essentially not taking too much risk. That the brain is hardwired to avoid risk. That's how we as a species have managed to survive and evolve. And so I think you're right, language is important here. And when we have words like failure, that inherently brings about, I'm going to make a mistake, I'm going to have risk, I'm going to inject uncertainty potentially into whatever it is I'm doing. We're hardwired to avoid that. That's like I said, it's how we've survived for a very long time as a species. And so with that in mind, then I wonder if we can maybe shift gears a little bit and just understand where you believe things are sort of going next in terms of some of the research you've done, some of the technologies you've looked at, and really in your new role as the Chief Innovation Officer for the Saab Group, what it is you're excited about in terms of, okay, where we might want to be thinking the company might be going as well.
Yeah. So one of the things is that we've been building and designing technology that we've been very forward-looking in a lot of things, and we built technology capabilities that we're still underusing. We could use a lot of technology we've been building in so many more different ways to achieve, especially with the new technologies coming in now, with the algorithms that it's building and the whole AI parts. And we have actually built systems that are prepared to receive that kind of capability. So that's something I'm looking forward to make happen. And then I think from a more general perspective, if we look at the capabilities of the machine learning and the AI we're seeing right now, if we manage to deploy that in a way not only to solve tasks that we don't want to spend time doing, or doing, rather not solve, doing tasks that we don't want to spend time doing, because that's one way of utilizing it, but actually using it to find new paths or new knowledge that we didn't really think of. That's something I'm really looking forward to. And also try to create frameworks for quickly utilizing new automation system that comes a year from now that we still not today know how they will look. That's something I'm really looking forward to.
Yeah, Rob, and I just kind of want to go a little bit deeper in that aspect, because when you think about it, this notion of to create, to skapa, right? That's the Swedish word for to create. You're kind of uniquely positioned on that sort of leading edge of creation of new capability, where you've seen the new capabilities in the grip and E, and then you go out and you test it, and then you go back to the drawing board. And I just wanted to get your thoughts on that iteration loop and how you accelerate that, and how you accelerate capability, and how important is the end user in that loop.
Yeah, that's a very good point. It's one of the purposes with how Whitney is designed was to make that loop super fast and truly, like, practically fast as well. Because sometimes it's one thing to design something and say, yeah, this is how it should work, but then to actually make that work in practice, that's a different thing. But we are using that right now, actually, during the development of the aircraft. And so if we find something that's maybe it is as designed, but it didn't work it didn't do what we intended it to do. It didn't solve the problem for us. Then we can easily, it's not painful anymore, I would say, to go back and say, hey, we want to change this, and then just change that and get it up and fly it again. And also this might sound to be qualified and certified as well, because that's something that is not in people's mind that it have to be, but that's actually a painful part of the whole system. Important, but sometimes time consuming. And having the end user in is super important, because sometimes you have an intention with a system and you design it and you solve the problem as it was a few years ago, or as it was from your perspective or your team's perspective. But then the end user comes in and see, we've changed how we use this, or actually our problem looks like this right now. And that discussion is so important, because maybe also when that comes up, a lot of times you realize, okay, so should we change it to solve the problem as it's described by the end user right now? And actually, I'm one of the end users a lot of times. So that's, sometimes I ask myself, okay, so should we change this to solve my issue today? Or should we change this to be able to solve tomorrow's issue, which I don't know how it is? And that's actually the approach we take a lot now, to be flexible in adapting.
How much of it is actually to change the decision loop of the adversary, to create problems for them to solve? And is that part of the design process?
Oh, yeah,
is that okay? Yeah,
definitely. You have to work with both those decision loops, right? Your own, to make it as fast as possible, and not only make the decision, but to be able to act, right? And that's the interaction with the aircraft. And we talk a lot about. So we started out talking about human machine interface or pilot vehicle interface. Now it's a lot about human machine collaboration, because I want to be able to work allocate and put tasks on the aircraft to a much higher level than I've done before, and then to be able to bring back that task. So because when I hand over one of those tasks to the aircraft, that decision loop is within the system now, is not in my brain anymore. But all of a sudden, I might have to be able to take it back, and that's more collaboration rather than pure work allocation. To be able to understand what the system is doing real fast when you need that, and the other way around, so the system can be more in your loop and help you out where you need it. And it's easy said, it's not easy done, but it's definitely not impossible. So we've done a lot of progress in that, which is interesting.
Well, it's funny. Well, it's not. It's actually it's a very intentional thing, and it's one of the reasons we planted Skapa here in San Diego, to get that proximity to the end users, to get that feedback loop, and to get to accelerate capability to solve their problems fast. And it's I've never interviewed a test pilot before, so it's really quite a fantastic perspective.
I mean, going from a really clear people-centric approach, we talk about end users, we're actually talking about people in this case, and everything you've just described there. And it's interesting listening to the language of moving from a human-machine interface to human-machine collaboration. It kind of begs the question that do we think that fast jets in, I don't know, 10, 15, 20 years maybe won't have people inside those cockpits?
I think, no, there will always be. No, I think there will be a combination. I think it's going to be a collaboration between, it will continue to be a human-machine collaboration, but that machine might not be the one you're sitting in. It might be flying next to you or further away probably. And I think that's how it's going to progress. We're already there in so many ways, but that will continue to evolve in the air domain, in the space domain, in the land domain, and also in everyday life. I'm pretty sure that we will be we are already interacting a lot with the machines or systems, and it's going to be interesting to see when we start to consider the machine to be less of a machine and more a collaboration, team member.
Yeah. I mean, it's just listening to you describe that, Marcus. I'm drawn to the example of Deep Blue and when they were able to use AI to basically win the game of Go. And that game's been around for thousands of years, and yet the algorithm and the model were able to put together moves that no human had ever done before. And so this is a speculative question now, but I'm wondering if one sees a future whereby there's a partnership teaming between manned aircraft and unmanned aircraft, where actually they would look to do moves in the air, which no person would look to do, and I wonder if there is enough curiosity, from our sort of aviators to embrace that.
Yeah, that's a good question. I think there definitely is curiosity. It's probably not with everyone, but there is. I know that, and I think that's a good point. If you let an algorithm or more machine learning system use a system for a task, that does not mean that the optimum way for that system to be used is the same as it would be for a human being. So, for instance, I think if it comes to holding a very specific angle or nailing a number, the machine will probably do that so much better than a human being all the time, and we'll probably utilize that in another way. When it comes to acting on very sparse data, sparse information, I think the human brain is still a lot better at that, I believe, and that's probably gonna affect how we're using the same system for the same task in different ways. And also, it's interesting. This have also been shown in research several times when you use hardware, for instance. I think with FPGAs were being used to identify specific tones with a machine learning system or algorithm. It turns out that it used the hardware in a way that was not at all intended or foreseen, and it was not even a part. It was not the software was the thing that was being tested, but the hardware was used to identify the tones in a way that no human had been thinking about. It's just the algorithm found out, I can use the hardware this way, and that's pretty interesting, I think. So it's kind of interesting to have these algorithms and let them loose on the systems and see what they find out.
Yeah, Rob, I want to take this just a little bit further and talk about a very sort of human quality for a machine. It's this notion of trust. How does trust or can trust develop between a human and machine? So just it's a wide open question. You are discovering the future each day in your role, not only at Saab, but at the European Space Agency. And so how does one develop trust between a human and a machine?
Yeah, that's also super important. A lot of times, I would say that technology is mature before we are sometimes, and that trust needs to be built. And I think it's important. That can probably not be skipped because then all of a sudden you will use the system wrong, or you will not just not use it. And so looking back to what I've seen, when we have implemented automation in the aircraft, a lot of times we have had to implement it first as a decision support or as a suggestion from the system, like, hey, do you want to do this because that looks wise? And then sure. Or sometimes like, I don't know, or something, yeah, sure, I'll do that. Yeah. And after a while, first, when someone comes and tell you, hey, we're going to automate this, like, no, that's not going to work.
Yeah.
And then when you put it in as a decision support, so after a while, you're like, oh, that's pretty good. Yeah, I'll do that. And after a while, you get annoyed and say, hey, why doesn't it just do this automatically?
Yeah.
It's like, yeah, that's what we said from the beginning, right? So that acceptance so you build that trust by doing it, right? By being there. Sometimes it's also so if you take it to a theater and you fly and use a system where your life depends on, and also, for instance, space station, if you go up there and you have to trust, you're trusting that system with your life, right? If the machine does not work, that's the end. And for me to build that trust, it comes about understanding how it works, and or at least what would the outcome be depending on what is happening. And when I get that knowledge, I start to trust the system. Or if I see it's acting, yeah.
I just wanted to share an example of this from my perspective. I was a captain of an LCS, 8,300 sensors, and a lot of automation. But there's a sense that a human had. I could tell when something was going to go wrong, by the sound of the engines and some smells, and are these instinctual things happening to you in the cockpit as well?
Oh yeah, definitely. Yeah. A lot of times, and it's most obvious when if you do simulations or malfunctions. Sometimes you feel slower than you expect from yourself. Yeah. And I think that's because you're lacking input. You're lacking that vibration or the sound, or just a chain of small events which you don't notice each and every event, but your subconscious picked them up. And then all of a sudden you get that feeling, ooh, there's got to be something wrong here. What should I look for? Yeah. And there's no hard data that you can point to, but that something will happen. And a lot of time you're right. And when we do testing, a lot of times I try to tell my pilots that we'll tell each other that if you sense that there is something wrong, you're probably right. Because a lot of times you're trying doing a flight control system thing or something. It's like, I can't say what it is right now, but there's something. And if you have that feeling, you should dive a little bit deeper and try to find it out. And I think that's that perception, that level of, anomaly detection. I don't know if that's there in the machine yet. But
yeah. Rob, any follow-ups there? Or?
Yeah, we could talk an awful lot about this notion of trust. I feel it's so fundamental to, we're all national security professionals, and it's fundamental to that arena, quite frankly, on many, many different levels. Yeah. And I suppose that when one thinks about understanding how it works, whatever it might be, and you start to layer in artificial intelligence, you start to layer in large language models, but by definition, the way those models are built, it's not always clear the explainability of those sorts of models. And so I'm just wondering how we can still build and maintain trust in the systems that we create essentially in the company, where you're layering in new technologies that perhaps it's difficult to achieve that level of explainability.
Yeah, I think that's really interesting. Sometimes when I want us to use these new capabilities and technology for research, for instance, but then I get questioned like, how would you know that it's not that is not a hallucination. I'm like, well, how do we know that with people? Do peer reviews, we make sure that we replicate and see that we get the same results. I guess maybe we can employ the same type of approach to systems that are not humans. And when it comes to consider an algorithm or a system or AI system to be almost human or have not human, but more trusted, I think that will be challenging. Sometimes it feels like it shouldn't be that hard. But on the other hand, if we look at the small difference between us human beings, that's the only thing that's required for us to not trust the other human. That's so then looking at a totally different being or system or whatever it is, that will probably be challenging when it gets close enough to us. I think right now it's still not human enough to feel threatening that way, maybe. But when it gets closer, it's going to be interesting to see whether we can accept that and trust that or not.
So it almost feels like, in fact, I use the word feels there. So it almost feels like trust is more important than performance. So, for example, where you have, the Mark 1 eyeball, if you've got, you're flying on the visual flight rules and, you're looking around and what have you. And so even though maybe you'd have sensors that can see things further out, and if perhaps you can't really 100% understand how those sensors work and explainability, even though their performance 999 times out of 1,000 is perhaps better than your eyeball, if there's that hint of like distrust in there, and I'm not trying to put words in your mouth here, but it feels like trust in our line of work is more important than performance.
Yeah. Yes. On the other hand, if you have good performance, it will probably build trust. If the performance is low and you see that over and over again, there will be no trust.
Yeah.
But if I see that the performance is good, if that is better than my eyeball Mark 1.0, then after a while, I will probably trust that system. So take flying as a good example. If you have a small attitude indicator, you go into a cloud, and when you learn how to fly, you fly outside of the clouds and you see that, okay, yeah, this line is matching the horizon out there. And when I'm turning, it's still matching the horizon, even though my vestibular system tells me something else, it's still matching the horizon. And then you build that trust. And then when you enter clouds, and if you have a spatial disorientation, I would say it's not a problem to trust the instrument if you have seen that it's been working, it has high performance. And I can just look at that. And even though my system is telling me you're 30 degrees bank left, and I see, nope, I'm not. I see on the instrument that I am wings level. I can still trust that because I've seen it performing before. So I think performance is important to build trust. But without trust, it doesn't matter how well it performs. So that's a good point.
Yeah, Marcus, so we've gone down a few, we've gone vertical on some very important topics. I wonder if there's anything that you just want to address in your new role as Chief Innovation Officer, or just any highlights from your trip here to California, or just what's on your mind as you get ready to really act out your vision at Saab?
Well, I guess there are several things. Maybe first of all, the trip here to California has been fantastic. I think this is really an innovation hub, which I love. It's great to see this work here. And when it comes to innovation in general and my role at Saab, I think what I would like to communicate is if you think that, if you have an idea and you think that makes sense, please don't stop yourself and ask people around you, and just make a double check. And if there is no good reason not to pursue that, you should definitely pursue that. And also be very careful with the word impossible. Just know that difficult and impossible is not the same thing. Unlikely and impossible is not the same thing. And just if you still believe it can be done, it probably can be done.
Yeah, for me, that's the biggest takeaway from this conversation today. Your view of impossible and what and not accepting that notion. It's been a really enjoyable chat from my perspective. It's been mind blowing. I really appreciate you sort of taking us in the cockpit. Rob, what are you taking away from this conversation?
So I think it's more how central that the person is, the human is. Talking about your points on the gripping as the chief test pilot and the role of the end users and how that's so important. Every time, everything we've touched on here, it all comes back to the person, the individual, and that mindset, and really being bold and ambitious and trying things. Marcus, it's been a pleasure. Thank you. Thank you so much for joining us. And to our listeners and viewers, thank you all for joining us on today's episode of the Skapa Podcast. Do not forget to like and subscribe wherever you get your podcast.
Thank you very much, Marcus.
Thank you.